All right, this is your 2.4 notes. So this section is algebra on functions, so as far as what you are and are not allowed to do between two functions. The three for this section are going to be these top three bullets. The last one is technically algebra, so I do like to list it in this section, but we haven't, it's covered all by itself down the road. So don't worry about that last one just yet. And on that algebra with functions, we want to make sure, a little typo there on my part, you can add or subtract. So we want to make sure we get the plus or minus in there correctly. All right, so example 1, f of x is 2x minus x squared and g of x is 3x plus 1. Find each of the following. So we're looking for f plus g of 4, so we want to use our rules above. So in general, f plus g of 4 is equivalent to f of 4 plus g of 4. So I like to go compute this off on the side. I don't like having 500,000 things written within my work. So I'm going to come down here. Well, yeah, I'm going to scooch this way, and I'll work down here. So f of 4, I want to figure out. Remember, that means to plug in 4 for x. So 2 times 4 minus 4 squared. All right, so we get 2 times 4 is 8, and 4 squared is 16. 8 minus 16, negative 8. Right, and then I need g of 4, so I'm going to draw a little separation here. I think I can squeeze it in. Actually, a little scoochy up. Scoochy. All right, g of 4. So now we're using the function g. And g was 3x plus 1, so we're doing 3 times 4 plus 1. 3 times 4 is 12. And add 1, and we get 13. So I like to do these off to the side so that this equation isn't like both of those two giant things strung out together. And then I just go plug them in. So for what we need here, again, I want to make sure it's not looking too confusing. F of 4 was negative 8 plus, and g of 4 was 13. Negative 8 plus 13 is 5. Therefore, f plus g of 4 is 5. All right, for B, separation. All right, being asked to compute f times g of negative 1. So that is equivalent to f of negative 1 times g of negative 1. It's implied multiplication if you just list them side by side. If you want to put the little multiplication dot between, you can. All right, so I'm going off to the side again. F of negative 1. All right, f of negative 1 is 2x minus x squared. So 2 times negative 1 minus negative 1 quantity squared. We get a negative 2. Minus, order of operations, negative 1 squared is 1. So then we have negative 2 minus 1, negative 3. For g of negative 1, g is 3x plus 1, so 3 times negative 1 plus 1 is negative 3 plus 1, which is negative 2. And then I go plug them in. So with this one, just be careful. If you don't put them in parentheses, it's likely you're going to subtract instead. So when I plug in, I'm going to leave some bubbles. So f of negative 1 is negative 3 times g of negative 1 was negative 2. And then negative 3 times negative 2 is a positive 6. So fg of negative 1 is 6. C. F minus g of negative 3. So this is going to be equivalent to f of negative 3 minus, not a lot of room, g of negative 3. So I can scooch it over just a tad. There we go. All right, so I like to go off to the side. F of negative 3 is, I forgot f, can't remember it, 2x minus x squared. So 2 times negative 3 minus negative 3 quantity squared. 2 times negative 3 is negative 6. minus negative 3 quantity squared 9, we have negative 15. G of negative 3. G was 3x plus 1. So 3 times negative 3 plus 1, negative 9 plus 1, negative 8. And then we want to go plug in. So f of negative 3 is negative 15 minus g of negative 3, negative 8. So we have negative 15 minus a negative is a positive, and negative 15 plus 8 is negative 7. So let's see if I can squeeze it in here. F minus g of negative 3 is negative 7. All right, so there is your algebra on function values. All right, for example 2, it says let f of x equal 2x minus x squared, so same as before, and g of x is 3x plus 1, also the same. Now we are looking for each function and giving the domain associated. So difference here is you are not subbing in a specific value for x, you are going to leave it with the arbitrary x to create a new function. All right, so here we have h of x is f plus g. So h of x is f of x plus g of x. So with this one, we can't go off to the side and find the values because we're leaving it as x. So we got to do all our work with them. All right, so I'm going to go get f and plug it in parentheses. It is 2x minus x squared. Close them, put another plus sign, and open a new set of parentheses. Now I'm going to go get g, 3x plus 1. So then you want to look at it, always plug it in parentheses, and then you can back up and look and decide whether those are necessary or not. In this case, those are not necessary because there's nothing that needs distributing. So I'm going to drop them. And then we're combining like terms. So I would usually list the x squared term first. 2x plus 3x is 5x. It does not look like a 5. And then our lonely plus 1 at the back. And there's nothing else we can do here. So this is our new function, which I asked you to call h. X plus 1. So the first thing we were asked to do is find h. Second thing we were asked to do was give the domain. So as far as the domain, you may write your answer in set or interval as always. So same considerations as before. Denominators, square roots, and logs is what you are looking for. That's all we've got to worry about. All right, so if I'm looking at my function h, we're not looking at f and g separately, we're looking at the new function h. I have no denominator, so no issue with 0. I have no square roots. I have no logs. I have no problems. If you say no, 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 you have no problems. So the domain of h is all real numbers in whichever notation you would like to write it in. All right. B. We are asked to compute the function k of x, which is f over g of x. So k of x is going to be f of x, using our rules at the beginning, over g of x. So I'm going to go get my function f. I'm going to get my main division bar in here first. I'm going to go get my function f, and I'm going to go get my function g. I don't know if that's enough room, so I'll put them later. All right, f was 2x minus x squared. So f is into the numerator, 2x minus x squared. And I always like to plug it in parentheses just to make sure they're not super necessary. G involved a 3, 3x plus 1. So all over g, which was 3x plus 1. And then again, I like my bubbles just to make sure it stays organized. So if I look at this, those parentheses are not needed, so I'm going to just drop them. 2x minus x squared all over 3x plus 1. So if I look at this, there is no algebra we can do with this. There's no combining, no nothing. So this is as simplified as I can make the function, which I asked you to call k. So this is our k of x. So now that we have k, domain. Same three questions. Denominator, square roots, logs. Denominator, square roots, logs every single time. So if you look at this function, you have a denominator, which means you may have a problem. My denominator is 3x plus 1. Denominators are not allowed to equal 0, so I pull my denominator in its entirety and say it cannot be 0. I'm going to move my 1 over. I'm going to divide both sides by 3. And x cannot equal negative 1/3. So I know the restriction, write the domain however you prefer. I'm going to go with set here, so open squiggle, x such that x cannot equal negative 1/3, close squiggle. Okay, function domain. Now let's scooch this over just so it's lined up a little bit prettier. So on these questions, if you are not asked anything about the domain, you do not need to write it down. So just make sure you read carefully so you know about that. All right, example 3. F of x is 3 divided by x plus 1, and g of x is x minus 2. We're looking for each function and the corresponding domain. So f plus g, we're going to call a. So a of x is going to be f of x plus g of x. So then I'm going to go get my function f, 3 divided by x plus 1. Plus, and then I'm going to go get my function g, x minus 2. All right, so as far as what to do when, if the directions do not ask you to simplify this function, you do not have to simplify this function. So we would simply just leave our function, because it does not say simplify, as 3 over x plus 1 plus x minus 2. Okay, so once you have your function, and I typically do not ask you to simplify this type of function because it is a little bit complicated on the simplifying. So just read carefully. Once you have your function, it does say domain, so now we're going to look at our domain. So same questions, denominator, square roots, logs. Burn that into your head, denominator, square roots, logs. I have a denominator. Whatever is in my denominator is not allowed to be 0. So I pull my denominator in its entirety, x plus 1, and say it can't be 0. We're going to move our 1 over. And we get x cannot equal negative 1, and then notation of choice. So the domain of A, I'm going to go with interval just for something different. I can go from negative infinity. I have to hop over negative 1, continue on the other side of negative 1, and then I can go to infinity. So function, domain. If it does not say give the domain, you do not have to. All right, b. Function b of x is f minus g of x. All right, so b of x, again using our rules, is going to be f of x minus g of x. Okay. So I'm going to go get f, which I can't remember again, 3 over x plus 1. So I always put it in a set of parentheses originally, minus, and then I'm going to go get g, x minus 2. And then we look at what we have. So in this case, those parentheses are super, super important that you do get them written in, because that minus sign in front of g does have to go to the x and the negative 2. So it's not going to affect the fraction since the fraction's on the front. So that's going to stay 3 over x plus 1. And then we get minus x plus 2. So as far as functions, this is as simplified as you need to go with it. We're not going to try to create a single fraction here. So this is going to be your function b of x. So in rectangle mode. Come on, there we go. All right, once again, it does say give the domain for each of these, so I'm gonna go through my denominator, square root, log. Notice the pattern here, we're really only worried about that denominator. So I do have a denominator. Restriction when I have one is it is not allowed to be 0. Happens to be the same denominator that we got in A. So I'm still gonna move my 1 over. And we get x cannot be -1. So I'm gonna write this one in set. The domain of, that's a terrible B, of B, open squiggle, x such that x cannot equal -1, close squiggle. So, function, domain. All right, C, separation. Function C of x is f of x times g of x. So C is going to be f of x times g of x. So I'm going to go get f. 3 over x plus 1. One of these days, one of these seconds I'll memorize it. 3 over x plus 1. I like my bowls in parentheses because when they're not there and you need them, it's wrong. So it doesn't hurt to put them there. And then g, which is x minus 2. Times x minus 2. All right, as far as this function goes, very, very easy for simplifying, so we will be looking at simplifying that. So the idea here is this is over 1. So we're thinking numerator times numerator, denominator times denominator. So top times top, bottom times bottom. So my numerator on the first fraction is 3 times the numerator on the second fraction is x minus 2 over denominator times denominator, or bottom times bottom, denominator x plus 1 times denominator 1, which is not necessary because 1 times anything is just itself. So we wind up here. As far as simplifying goes, it's going to depend on what you look at. Some people call this simplified, so I would accept this as an answer. It's fine with me, because there's disadvantages and advantages to leaving it factored versus unfactored. So I would accept this. If you did choose to distribute that 3 through, you would get 3x minus 6 all over the x plus 1, and I'm good with that one too. So you could write it either way. Let's see if I can double box. There we go. So this or that, I'm good with either one. So then again, domain. It doesn't matter which case you look at, you do have a denominator and you have the exact same thing in the denominator. So x plus 1 cannot be 0. We move our 1 over again for the third time. And we get that x cannot equal -1. So notation of choice, negative infinity, -1, and hop, and continue on. So again, this one, you do want to slide that multiplication together so that it's a nice fraction. However, on B, I'm not going to make you try to simplify to a single fraction. We're going to leave B alone. So here is your ABC. We'll worry about the next two in just a second, in case you need to look at those. You can freeze it. All right, for the next two, we are still working with our same functions, but I do want to change this. I had a little typo there. I want to stick with the theme. That should be D. So we're going to call it D. Let me go copy my functions down just so we don't have to hunt for them. Copy. I'll stick them right there so we don't scroll so far to see them. All right. Oops. There we go. All right, D of x is f over g of x. So D of x is going to be f of x divided by g of x. So I got my fraction bar, and I'm going to go get my f, which is something. 3 over x plus 1, so you can be careful here. 3 over x plus 1, I like parentheses, over g, which is x minus 2. All right, so here, you need to be very, very careful. So as far as lining it up, notice I have my f in parentheses. If you don't have that f in parentheses, it's not wrong. However, make sure your division bar in f is smaller. You need to know what the main division bar is versus the small division bar. You don't want to get those mixed up. So if it does not say to simplify, I'm perfectly fine with you leaving the d of x as 3 over x plus 1 all over, notice the difference in size and division bars, x minus 2. So if it doesn't say simplify, that's fine. All right, so here's where we're going to go look at domain. Again, denominators are a problem. We got fraction overload here, so you need to be very, very careful in your denominators. You have denominators, plural. So I call it the big and the baby. The big denominator is what you see in the large denominator right here, that x minus 2. That is the big denominator. The big denominator is a denominator. It is not allowed to equal 0. And then you have what I like to call the baby denominator, which is in the numerator of that main fraction bar. Even though it's a baby denominator, it is still a denominator, which means it is still not allowed to be 0. So with this type of function, when you're on fraction overkill, it's bigs and babies. You pull the big denominator and say it's not allowed to equal 0. You pull the baby denominator and say it's not allowed to be 0. So you wind up with 2 restrictions in this case. So each separately, we're going to move the 2 over for the first problem. X cannot equal 2. And we're going to move the 1 over in the second issue. So x cannot be negative 1. So I have 2 values that I need to throw out. So the domain of D, and I'll write this one both ways, open squiggle, x such that, and we just simply throw them both out. X cannot be negative 1, and we just separate by a comma, 2. And then interval-wise, you gotta expand your intervals here. So before we only had 2 intervals. When you add a second restriction, it jumps to 3 intervals. So I still start at negative infinity, and then you just hop over each restriction one at a time. So the first one we gotta hop over is negative 1, and then I will continue on at negative 1, but we had a second problem at 2. So now I'm gonna hop over 2 as well before continuing on to positive infinity. So you gotta make 2 hops. Okay. All right, E is G minus F. So the function G, so E of X is G of X minus F of X. So again, use your parentheses. G is, I think, X minus 2. Yay, I finally memorized it on the last one. X minus 2 minus, I'm going to open another set of parentheses, 3 over our f, x, I think it was plus 1. Whoops. Plus 1? Yes, plus 1. Okay. All right, so in this case, as far as the subtraction, you just need to be very, very careful how you write. There's nothing wrong with leaving it like this. The parentheses aren't super important as long as you're very careful. So I would be dropping my parentheses on the x minus 2. And for the fraction, you have 2 choices. You can leave that subtraction sign here and leave the fraction as is, or you could change it to a plus and attach the negative to the 3. Totally up to you. I would probably leave it just to make sure I don't mess it up. So this is our function E of X, and I'm not going to make you simplify this type either. So domain, same thing with your domain. You're looking for denominators, and we got one. X plus 1 is not allowed to be 0. So we subtract 1 from both sides, and we get x cannot be negative 1. And then you choose your notation of choice. Negative infinity, 1 hop, and continue. So here's your E and F if you need to freeze those to look at. All right. So the next one is a you try it. So it's all completely filled out in some cases. So like A, normally I would not make you simplify. I did show you the algebra for simplifying in case you want to look at it. And then over here for D, I did show you the simplifying process again in case you would like to look at it once it gets filled out.